Yes. Good morning, everyone. Welcome to another session of structural analysis. So, in the previous classes and previous videos, we have seen moment distribution method, isn't it? So, we have done few problems. How many problems you have done so far? I think 3 to 4 problems we have done in moment distribution method. So, we will continue the same thing. Since we have, the last problem was a cantilever beam, right? The last problem which we have studied is cantilever beam. If you see the videos, I have gone through the previous videos and the problem was cantilever beam. Now we'll move for another question, that is non-sway frame. What do you mean by non-sway frame? What do you mean by frame? A frame is nothing but which consists of horizontal members as well as vertical members, is nothing but your frame. And in some cases what happens, the frame will sway and few frames will not sway. So the frames, if the loading is unsymmetric, then the frame will sway either on left or right side, whereas if the loading is symmetric, then the entire frame will not sway anywhere. Okay. Yeah. So now write down the question. The question is, analyze the frame shown in figure using moment distribution method. Yes, it is very important question. Copy down the frame very carefully. The load is 100 kilonewton and I for this one is 1.5 I and this one is 3 meter and this is also 1.5 I, and here we have a point load of at a distance of, this is 2.5 meter and this is 1.5 meter. This is I, and this distance is 4 meter. This is 2I. Then here we have 3 meter span, and it is 1.5 I. And we have a UDL of intensity 50 kilonewton per meter. Okay, this is the question given to us. Okay, just copy down this one. So this load is 50 kilonewton. Okay. So this is the frame given to us. Now we have to calculate all the moments. Along with that, we have to draw shear force diagram bending moment diagram for this figure. So what we do, before that we'll name this as A, B, C, D, E, F. Okay. We have named all the points A, B, C, D and F. Okay. So what is the first thing we do in our moment distribution method and slope deflection method? The very first thing we do is fixed end moments. We calculate what? Fixed end moments. First we have to calculate fixed end moments. So how to calculate fixed end moment? See here, I will write here fixed end moments. So MF AB, fixed end moment for AB will be how much? Minus WL square by 12, right? So whether it should be plus or minus? Minus WL square by 12. How? If you fix this one, so when the beam gets deflected, to retain or to maintain the deflection in its original position, to take the beam in its original position, this support will try to create anti-clockwise moment, whereas here it will create clockwise moment. It is nothing but like this, right? We have a beam like this, and if because of this UDL, my beam will try to get deflected in downward direction. So what these supports will do, it will try to create, one will create anti-clockwise moment and another one will create clockwise moment, so that this is point A and B. So this will be MF AB and this will be MF BA. Yes, you remember this one? Right. So MF AB is equal to minus WL square by 12, which means minus W. What is W? 50 into what is the span? 3 square divided by 12. Tell me the value. 50 into 3 square, 50 into 9 divided by 12. 30? 37.5 kilonewton meter minus. Why? Because it is anti-clockwise, right? Similarly, MF BA is equal to plus WL square by 12, which is equal to plus 50 into 3 square divided by 12. Now what will be the value? Plus 37.5 kilonewton meter. Yes? Do we have any doubts still here? No doubts. It's very simple. The same thing we are doing in, we have done in the same thing in first unit also, right? That is slope deflection method. Now we will go for another span, that is span BC. Okay. What about span BC? MF BC is equal to minus. Why minus? See here, again we'll be having, if you consider this span, we'll be having again anti-clockwise moment at B and clockwise moment at C. So minus WA B square by L square. So minus, what is W? 50 into A is 1.5 into 2.5 square divided by 4 square. So tell me the value. Minus 29.29 kilonewton meter. Next is MF CB is equal to plus W A square B by L square, which is equal to plus 50 into 1.5 whole square into 2.5 divided by 4 square. Tell me the value for this one. This value will be positive, right? 17.56 kilonewton meter. Now we have completed MF, this span, that is AB is completed, BC is completed. Now we'll move to CD. So for span CD, MF CD is equal to minus WL by 4. Check it in the previous problems whether it is WL by 4 or WL by 8. For central point load, fixed end moment will be WL by 4, WL by 8, right? WL by 8. So minus WL by 8. So for bending moment it is WL by 4. For bending moment. For fixed end moment it is WL by 8. So minus, what is W over there? 100. 100 into 4 by 8. Tell me the value. How much? 50. Minus 50 kilonewton meter. What about MFDC now? Same, plus WL by 8 is equal to plus 100 into 4 by 8 is equal to plus 50 kilonewton meter. Okay. Now we have calculated fixed end moment for the horizontal members, isn't it? Now we have to calculate fixed end moment for vertical members. So if you see vertical members, the first vertical member is BE. First vertical member is BE. Do we have any load on BE? No. No horizontal loading, isn't it? What about span CD? CF? Span CF is also does not have any horizontal loading, isn't it? So what will happen on span BE, that is MF BE is equal to MF EB is equal to 0. Fixed end moment at this point and this point will be 0 because there is no lateral loading or horizontal loading on the span, isn't it? However, it has vertical loading, isn't it? It has vertical loading, but it does not have any external horizontal force, right? Similarly for MF CF is equal to MF FC is equal to 0. No horizontal loading or lateral loading on this vertical member again, right? If you have any vertical horizontal loading, then we will get fixed end moments on that. Okay, copy down this one. So now after calculation of fixed end moments, what is the next step we do? We calculate distribution factor, isn't it? So we'll calculate distribution factor for these joints. How many joints we have in this frame? 5 joints. The point at which more than 2 members or more than 1 member is getting connected, then that point is said to be joint. See here, we have one joint here, that is B. We have how many members connected to joint B? One member is BA, BC and BE. 3 members are connected to one joint. Okay. So first we will draw the table. What is that? Distribution table, right? Distribution factor. Distribution factor. So first is joint, then member, then relative stiffness, then total relative stiffness, then we have distribution factor. So this is relative stiffness is denoted by K and total relative stiffness is denoted by sigma K. And what about distribution factor? Distribution factor is the ratio of relative stiffness to total relative stiffness, that is K by sigma K. So first we will take our first joint, that is joint B, right? So joint B. So how many members are connected to joint B? First is BA, then BC, then BE. There are totally how many members? 3 members connected to one joint, isn't it? So now how to calculate relative stiffness? See here at joint B, if you see from B to A, at point A we have a hinge support, isn't it? So whenever you see hinge support, whenever you see hinge support, then relative stiffness will be, relative stiffness is given as 3I by 4L. What is that? 3I by 4L. What about BC? See here. BC, we have a joint here, and after that we have fixed support. So whenever you have extra support, then our relative stiffness is given as I by L. Okay. Similarly, for member BE, see here BE, we have fixed support. So relative stiffness is given as again I by L. So now we will calculate these values. That is, we have 3 for span BA. What is the value of I we have? That is 1.5 I. So 3 into 1.5 I divided by 4 is the constant value. What is the length or what is the span? 3 meter, isn't it? Member span BA, span of member BA is how much? 3 meters. So here it is 3. Now calculate this one. This 3 and this 3 will get cancelled. 1.5 I divided by 4. How much? 0.375 I. Yes. Next is I by L for span BC. See there, for span BC, what is the value of I? 1. So this is I by, what is the length there? 2.5 plus 1.5 is 4. So this will be 0.25 I. Now we'll move to span BE. What is there? 4 meters, right? So what is the value of I? 2I by 4. So how much? 0.5 I. Understood this one? Yes? Able to follow? Yes. Now, what is the value for total relative? What is this total relative stiffness? Total relative stiffness is nothing but summation or addition of all these values. 0.25, 0.75 plus 0.375, 1 point. So the total summation is 1.125 I. Okay. Now, what is the distribution factor for this one? K by sigma K, that is 0.375 I divided by 1.125 I. How much? 0. This one is 0.333. Yes. Next 0.25 divided by again 1.125. 0.22 and 2. Next 0.5 divided by 1.1. 0.444. Understood this one, how we got these things? Yes. What is the next joint we have? One is B. Next is C. Again at C we have 3 members. That is CB, CD and CF. So the same thing we will be doing here. We have CB, then we have CD, then CF. Now we have to calculate relative stiffness for CB. Now see here, from C to B, if you see here, it is supported here. Okay. Then again we have one more support here. So whenever we have extra support beyond B, then we'll consider that as fixed support. Yes. In the previous case, here there is no extra support, but here for CB we have extra support. So what we will consider there? We assume that it is fixed. So what will be the relative stiffness there? I by L only. So this will be I by L. What about CD? See CD, it is already fixed here. So it will be I by L. What about CF? 3I by 4L, because we do not have any. If we have one more support over here, then it will be considered as fixed. But since we do not have any further support, or beyond that support we do not have anything, so we will consider that as hinge support. So that will be 3I by 4L. Now CB, for span CB, what is I? I by 4, isn't it? So 0.25 I. Next, for span CD, what is I? 1.5 I divided by 4, right? Tell me the value. 0.375 I. Next is 3I by 4L. So 3, what is I for span CF? 1.5 I divided by 4 into, what is the span? 3 meter. 0. How much? 375. 375 I. Okay. Next, if you add all these terms, you will get sigma k. So here we do not have I. No I. Why? Because I by I will get cancelled. Right? This is 1, entirely 1. So what will be these values? I, 1I, right? So 0.25, 0.375, and here also 0.375. Okay. So we have all the distribution factors for BA, BC, BE, CB, CD and CF. Understood this one? Till here it's same, right? Okay, copy down. We'll move to the final step, that is moment distribution table. Okay, very important. Here, see here we have horizontal members, along with that we have vertical members. So I request everyone to please see here very carefully how we are solving these vertical members. Okay, so it is nothing but a practical problem, right? We have continuous slab like this. We have one portion and we have one pillar over here. Then we have one more portion. Then again we have one more pillar or column. Then again we have a fixed end on the corner. So how to solve these type of problems? Using moment distribution method. Okay. So the softwares which we use nowadays, that is StatPro or eTabs and so many softwares we have for the calculation of moments. All the softwares which are actually available are actually meant to calculate moments only. So once you get moments, substitute those values in Excel file, you can get the design. That is how many number of steel, area of steel, or a number of rods or number of steel bars. That we can easily calculate with the help of Excel file also. But calculation of moments needs some important concepts. Okay, so these things will help us. The softwares will give you the moments. Sometimes the software may make mistakes. Many times the software may make mistakes. So to overcome those mistakes, we need to understand how the software is actually calculating these things and how practically we solve and what will be the practical conditions on the site. Okay, so many things will be considering. So now in the first case, while solving these type of problems, first we consider the entire horizontal beam. Okay, see the beam, we have A, B, C, D, right? A, B, C, D, and these vertical members, that is BE and CF, these are dependent members. These are what? Dependent members on horizontal beam, isn't it? These are all vertical members are dependent on horizontal members, whereas horizontal members are dependent on external loading, isn't it? So what we do, first we take the horizontal members. What we take? We take horizontal members. Now see here how to solve that one using moment distribution method. Now before that, I will try to draw the beam. Yes, in the previous problems what I was doing, I was trying to draw the entire beam, right? The same thing I will do here. Here it is fixed. Here we have one support here. We have one more support over here, and we have a hinge support at the corner, isn't it? So this is A, B, C and D. So this is nothing but your rigid support, okay? This is what? Rigid support, okay? So we'll draw the table like this. So we'll do one thing, we'll shift C somewhat closer to point B. So that we can get some more space. C, okay. So what are the after writing these things, the next very first thing which we do is we try to place our distribution factors. So what are the distribution factors we got for BA? 0.333, right? What is the distribution factor for BC we got? 0.222, right? What is the next distribution factor we got for CB? 0.25, and this is 0.375. So these are the distribution factors we have calculated using relative stiffness, isn't it? Yes? Till here, no doubts, right? It's very simple. Whatever the values we have, that is for BA, BC, and this is for CB and CD. There are no vertical members. There are vertical members in the frame, but we are not using here. We will calculate after calculation of the horizontal members. Okay. So this is your distribution factor. After writing distribution factor, what is the next thing we do? Fixed end moments. So what are the fixed end moments we got for AB, MF AB? Minus or plus? Minus 37.5. Then what about BA? Plus 37.5. Yes. Please reduce your volumes. The video is getting recorded, so please reduce your volumes. Okay. Any one person can tell me the values. Next BC. What is the fixed end moment for BC? Minus 29.29. Next for CB 17.56. Then next value is minus 50, and this is plus 50, right? So these are our fixed end moments. Now as soon as you write down all the fixed end moments, see the beam, we have a hinge support. The beam has hinge support. So, and we know hinge support does not have any moment. Hinge support does not have any moment. So when there is no fixed end moment or moment at hinge support, we have here some value. So what we do? We try to make this value as 0. How? We have done in the previous problems. How? See here it is minus 37.5. So what we will do? Add 37.5 here and give 50% of the moment to the neighboring support. That is 37.5 divided by 2 is how much? 18.75. Yes, tell me the value. 37.5 divided by 2. How much? 18.75. So we have given this value. Next, we will write the same value, that is minus 29.29, then 17.56 minus 50 and plus 50. Okay. So now add these values. Now this step is known as releasing, this step is known as releasing point A, releasing point A. What we are doing here, we are trying to make this moment as 0. So whenever we make this moment as 0, we try to give 50% of the moment to the neighboring support. Okay, what happens, you know, these type of problems when you can get is, suppose for example, please concentrate here. Suppose for example, we have a building over here like this. Okay, this is a building standing right over here. Okay, very carefully observe here, and I want to construct one more building over here and I want to join here. Okay, I want to join one more building, I want to construct one more building at this location. Okay, since we are doing here, right, so many buildings are, 50% of the slab they have casted, then after that they are trying to cast another portion, right. First they have casted this portion initially, then they have casted another slab, right, they have done like this. So what the same thing is happening here. So this is the older slab, this one is older slab and older beam. They will project rods from this slab rods as well as beam rods. Okay, so when I want to construct my new building or new structure over here, so what I will do, I will join here my rods, the old rods will get connected to the new building. Okay, so when you design this beam, see, we cannot directly place the column adjacent to this previous column. Why? Because if you excavate, the footing will come into obstruction, isn't it? So suppose this is one column over here, this is the footing, right? I cannot construct one more column over here. So the column will be somewhere at least 5 feet or 10 feet away from the existing column. So what we do, we try to connect this one, and we assume that 50% of the moment of this one will be taken up by this column. This column will not take any moment. We try to consider this support as hinge support and this column as fixed support, and we assume that, and or else we actually consider that whatever the moment which is acting over there will be taken up by this one. So when you design this beam, when you design this particular beam, what we do, we add more moment so that we'll get more steel. Okay, 10 kilonewton meter will have specific amount of steel. If you take more amount of moment, then again ultimately steel will also get increased. The same thing is happening over here. So this is nothing but the old building. We are trying to connect this one. So 50% of the moment will be taken care by the neighboring support. Okay, you will come across these type of things in future. Okay, so 50% we have to share with the neighboring support or column. So this is 18.75. These things does not have any effect. Okay, here only we will be having problem. After that, no problem. Continue. How much you want to continue, you can continue. Okay. Understood the concept of shifting or reducing the moment, right? If you are making the moment as 0, then 50% of that moment should be shared by the neighboring column or neighboring support. Okay. So now after this one, see here, this will be 0. Now add these two values, 56.25. What about this one? See, no need to add this one again. Otherwise, the thing is, there is no change here. Instead of writing the values, you may get confused. So there is no change, isn't it? There is no change. The moments are as it is. Only the changes are in this section. Now what about this one? Minus 29.29. Minus 29.29. Then it is 17.56 minus 50 and plus 15. Okay. So now these are my final moments. Okay. Now see here, this moment was 37.5. It has been increased to 56.25. Okay, why? Because the adjacent support is not taking any moment. So because depending upon this value, we have to design the steel or column or beam. Now, after this one, after fixed end moments, what is the next step we do? Balancing. Why? Because we need to maintain this as 0, right? The summation of these moments should be 0. That is MBA plus MBC should be equal to 0, right? So what we will do here, what is the value you will get? 56. How to balance? 56.25 minus 29.29. How much? $56.25 minus 29.29. 26.96. And all of you, please see here. Whatever the values we are balancing over here, these values will be useful for the columns. Okay. See here, we are balancing over here, no? So we got this value as 26.96. So always remember, whenever you get these things, you try to write down those values. What is that? 26.96. So this is the value you got, right? So as soon as you get this value, what we have to do? We have to change its sign to, since it is positive, so what I will do? Minus 26.96. Minus 26.96 into distribution factor. Yes, I think you people have forgot all those things, right? We have to recall all those things. Minus 8.97. Then again here minus 26.96 into 0.222. Minus 5.98. Okay. Next is this value, right? 17.56 minus 50 is how much? How much? I'm writing here, okay? Minus 32.44. So since we got this value as minus, what we will do? We'll make it plus. So plus 32.44 into 0.25. 8.11. The same value should be multiplied with 0.375. How much? 12.165. Here, do we have to balance here? No balancing. This step is known as balancing. Now after this one, we will go for carry over moment. So what do you mean by carry over moment? Again, we will try to give this value to the neighboring support. So minus 8.97, shall I give this value to this support? No. Why? Because it is hinge support. It will not take any moment. It will give, but it will not take any moment. Okay. So I will not send this term this side. So this will be, I can take this value, isn't it? I can take this value, that is, it is 0, 0. What about here? 8.11 divided by 2 is how much? 4.055. What about 5.98 divided by 2? Minus 5.98 divided by 2? Minus 2.99. And what about here? You see, since here it is fixed support, it will take moment. So this will be 0. Then 12.165 divided by 2 is how much? 6.08. This step is known as carry over moment. Carry over moment. Now again you see here, it is 0 and 4.055. So that means MBA plus MBC will not be equal to 0, right? So again what we will do here? Balancing. Again balancing. So next see, 0 plus 4.055. 0 plus 4.055 is 4.055. Since the value is positive, what I will do? Make it negative. Now this minus 4.055 should be multiplied with 0. minus 1.35. 5. Okay. Minus 1.35. Next again minus 4.055 multiplied with distribution factor. Minus 0.909. Both are same, right? Next, we'll move to this one. Here we have minus 2.99 plus 0 is how much? So it is minus 2.99, right? So since it is negative, we'll make it as positive. So plus 2.99 into 0.25. 0.747. Yes. Next is 2.99 into 0.375. 1.121. Okay. Now here do we have to balance? No need of balancing here and no need of balancing over here also. Okay. So this step is balancing. After balancing, what we do? Yes, after balancing, carry over moment. So shall I send this value here? No. Why? Because it is simply support or hinge support. But here we can take this value, that is 0. Here we can send these values here. 0.747 divided by 2 is how much? 0.37, and this is minus 0.45. What about this one? This is 0 and 1.121, 0.56. So this is the step known as carry over moment. Okay. Now again you see the initial values. It has started from 56.25 to minus 20. There was large amount of variation, right? So the first variation was 26.96. Now we have reduced it to 0.37. So we'll do it once again. So the thing is, when you have to stop is when you get the least values, that is 0, the difference should be bare minimum. Okay. So see here, what is the difference here? 0.37. Previously it was minus 4.055. Beyond that it was minus 26.96. Now we are getting it as 0.37. Since it is positive, we'll make it as negative. So tell me the value. Minus 0.37 into 0.33. 0. Next. 0. Yes, is it correct? Minus or plus? Minus. Next is, see here, minus 0.45. This value is minus 0.45. This will be plus. So 0.45 into 0.25. 0.11. What about the next value? 0.168. No need to balance here. No need to balance here also. So this is the step of balancing. As soon as you balance, carry over moment. So no need of sending this value here. So this is 0 and here is, tell me, 0.11 divided by 2 is how much? 0.055, and here minus 0.04. Next here is 0.8. 0.084. Now if you see here carefully, all the values are in 0, 0.0, 0, 0.04, 0, 0.08, right? So that means the variation we can further calculate also, we can also calculate further, but since we have reached 0, 0.0, here also 0, 0.0, here also it is 0, 0.0, then what we'll do now? We'll stop our calculation and we'll add all the values. Okay. Now see here, tell me how we got this value 8.11, because you know what happens after writing in your notes very easily, copying down from the board, once you open the book, and surely we'll open the book before examinations, and that time Ahad sir will be somewhere and you will be somewhere. ये कैसा आया कि क्या आया कि नहीं मालूम, समझ में नहीं आ रहा, कीप इट डाउन, ये समझ में नहीं आ रहा, यस, ये नहीं समझ में आ रहा है, घुस रहा ही नहीं दिमाग में, नहीं. So see here, very carefully you see, how we got this 8.11, can you tell me? We have done here balancing. So see 17.56 minus 50, we got some value. What is that value? 32 minus 32.44. That minus 32.44 we have to make it plus. Then multiply with the distribution factor, respective distribution factors, you got this value. Okay. Yes. How we got this value? 8.11 divided by 2, we got this value. And how we got this value? 18.75. 50% of this moment has been shared by the neighboring support. Why? Since it is hinge support, this is what happened. Okay, able to follow? See, when you open this one, many confusions will come. So you have to carefully observe all these things, and along with that, you have to practice this one. Unless and until you don't practice, these numbers will not get digested easily. Okay, able to understand? Yes. So now we'll do one thing, we'll calculate, we'll add all the values. So see here, this will be 0. From where you will add? We have to add from here. Okay, this is releasing end A. This step is what? Releasing end A. That means we have made it 0. That is why this step we'll name it as releasing end A. Or else if there is roller support or hinge support at this point, we'll release end B. Okay. Now we'll add all the values from here, not from here. We'll add from here. So now tell me 56.25, 8.97, from here you add. From this line. How much?
45.81.
Huh?
45.81.
This is 40.81. What about next value? Add these values. $45.81 minus minus 31.82. Next value? 23.04. How much? 23.04. Next is? From here you should add. Minus 52. Next? 56. Now this is our capital MAB. This is capital MBA. This is capital MBC. Then MCB, MCD and MDC. Now you might be wondering, sir, MBA plus MBC should be equal to 0. But here it is not equal to 0, right? Why? Because we have MBE also, right? We have MBE, that we have to calculate. Then only it will be MBA plus MBC plus MBE equal to 0. Okay, copy down this one. I have written these values, right? These values 26.96, 4. These values will be using for the columns. Okay, so how we will use that to see now. Now we have vertical members, that is BE and CF, right? So see here how we draw that members. So it is B to E, and here it is C to F, right? We are considering the vertical members, that is B to E and C to F. Please stop writing, close your books, keep your pen down, fold your hands and see here. We will give sufficient amount of time to copy down all these things. So see here, B to E and C to F, right? So what is the distribution factor for BE? We got 0. For distribution factor for BE we got 0.444, and for the distribution factor for EB is how much? 0. No distribution factor, right? So I will write here 0. For B to E it is 0.44. For E to B it is 0, right? Similarly, from C to F, what is the distribution factor? 0.375, whereas here it is 0. So these are our distribution factor. This is distribution factor. Next is, we have fixed end moments also, right? So what is the fixed end moment for BE? 0. Right? Fixed end moment for BE is 0, and fixed end moment for EB is also 0. 0, 0. What is the fixed end moment for CF and FC? MF, CF and MF, FC? 0, right? Yes, these are our fixed end moments. Now our balancing will start. See, what is the first value we have taken? Minus 26.96. So this value minus 26.96 should be multiplied with the distribution factor, that is 0.444.
Minus 11.97.
How much? Minus? Yes, correct. Minus 11.97. Okay. What about this one? 0, because distribution factor itself is 0. Now this is for joint B. These values are written over here for joint B. For joint C, what is the next value? 32.44 plus 32.44 into 0.375. 12.165. Again, what about here? 0. So this is the step of balancing. As soon as you balance, what we do? Carryover moment. Again, in case of carryover moment, don't send this value here. Don't send this value here. Why? Because this member and this member are nowhere connected, isn't it? This and this are, these two are connected, right? BE is different, CF is different. So what we will do here in case of vertical members, we'll send this value here and this value here. Yes, able to follow? Yes. So minus 11.97 divided by 2 is how much?
5.98.
Minus 5.98, and this is 0. And here again we'll send this value to the neighboring support, that is C2F. But you see F, what happens here? It is hinge support. So hinge support, it will not take any moment. No need of giving me any burden. Okay. So here it will not take any moment. So it will be again 0 and 0. Able to understand this step? Yes. If I send this value here, there is no connection, isn't it? It is the connection is between B2E and C2F, right? So now this step is your carry over moment. Then after that again, what is the next thing we have done? Minus 4.055 into 0.444. How much? 1.8. 1.8 plus or minus? Minus, right? Because that value is minus, no? Next, minus 2.99, oh sorry, plus 2.99 into 0.375. Minus 1.121. Again this is 0. Okay. Next what we will do? Again carry over moment, isn't it? So this will be minus 0. This is plus, right? Yes, this is plus. So this one is 0.9. This is 0. What about this one? 0, 0. Why 0, 0? Because it is hinge support over there. Here it is fixed. That is why we are giving some value there. So this is balancing, and this is again carry over moment. Next, again you see, what is the next value we have? Don't see these values in case of columns. In case of pillars, don't try to balance these values. Whatever the value we have, 4.055 is over. Now we'll move to this value, that is minus 0.37 into 0.444. 0.164. This is 0. So this is minus 0.37, right? What about next value? 0.45 into 0.375. 0.168. Or else we do not require anything here. Next, all these values are over, no? Yes. Now what we will do? This is the step of balancing. Do one thing, that is carry over moment. Send this value here. This will be minus 0.82. 0.82. 0.082, and this value will be 0, 0, right? Now add these values. Yes, from starting. Why? Because we have not released anything over here, right? Minus 14 or 13? Check it once. Yes, minus 13.93. Then what about this one? Minus 5.98 minus 0.9 minus 0.082. $6.96 minus 6.96, right? Minus 6.96. Next, huh? 13.45, and this will be 0. So this is MF, MBE, this is MEB, and this is MCF and MFC. For your verification, we do one thing: MAB plus MBA plus MBE should be equal to 0. Check it. MBA plus MBA plus MBC, MBA plus MBC plus MBE should be equal to 0. Similarly, MCB plus MCD plus MCF should be equal to 0.
0.06.
This value is 0.06. What about this one? Yes. 0. Minus 0.03 or 0.03. Both are almost equal to 0, right? Understood? Yes. So this is how we calculate for the non-sway frame. This is non-sway, isn't it? It is not swaying anywhere. Okay? Copy down this one. Now we'll draw the bending moment diagram for this frame. So what will be the bending moment for span AB? See here, bending moment for span AB, that is WL square by 8, right? So W is how much? 50 into 3 square divided by 8. Tell me the value. 15. How much? Yes? 50? 56.25 kilonewton meter. Next, for span BC, W AB by L, right? So W is how much there? 50 into 1.5 into 2.5 divided by 4. 46 point. For span CD, WL by 4, right? So W is how much? 100 into 4 by 4, which is equal to 100 kilonewton meter. So I will draw the bending moment diagram here itself. So remove all the loadings. So the bending moment for span AB is 56.25. Whether it will be parabola or inclined line or triangle? Parabola, right? Why? Because it is UDL. So this distance will be 56.25. Next is 46.875. Since we have a point load over there at 1.5 meter and 2.5 meter, so this will be a triangle 46.875. Similarly here it is 100, right? So this is 100, so that is why the height is more, right? 100. Then what about the fixed end moments? Fixed end moments? Yes? Yes, whatever the values we have calculated, that is MAB, MBA. So this one will be 0, right? Why? Because it is hinge support. What about this value? What about the value of MBA? 45 point? Okay, 47.5. 37 or 47? 37. So 37 means somewhere here. So this is 37.5. Next is MBC. Okay, 29.29 means somewhere here. What about the value of MCB? 17 point. 17.56. Next, what is the value of MDC? Plus 50. MCD? Minus 50. MCD? Minus 36. So this is minus, so plus 50. And this value is? What is the value of MCD? 36.52. Okay. So these are the fixed end moments for the horizontal members. What about this one? We got some value for MEB. We got some value for MEB. What is that? Minus 13.93 for MBE. MBE is 13.93. What about MEB? 6.96. So this will be an inclined line, right? This is next. What about here? What is MCF? 13.45. Here it is 0, right? So this is the bending moment diagram for the frame. Okay, able to follow? Yes, copy down.